IB2 students, this is a copy of your paper 2 on the specimen exam. Read through the instructions. The difference here on this exam is that we're going to have to put all the answers, in the answer booklet. Anything that we write in the question booklet will not be looked at. So you're going to see that we're going to have to copy over some tables, draw graphs, put all our workings into the answer booklet. Additional instructions here before the first question. Again, use the answer booklet. Start each question on a new page. Okay, so you got to turn the page for a new question number. Show all your workings. Show your input for the calculator. If you're going to use graphs to find your solution, do a little sketch to show how you found the intersection or how you used the graphs. And there it is one more time. Show all working. Okay, so the first question, financial question. You can see that it comes from topic 1. This was in the core book, Sequences in Series. We studied the TVM solver, basically. Okay, time value of money. So the first question, we got... we're going to buy a car for 14,000 euros. It's a 6-year loan, 14% annual interest that's compounded quarterly. Okay, that's 4 quarters in each year. We are allowed to write in the question booklet with the understanding that the examiners aren't going to look at it. So 4 compounding periods. Find the repayment made in each quarter. All right, so we're going to do this question on the TVM solver, and we have to show our calculator input for the examiner. So I jumped right to it, sorry. Here we go. We go apps, finance, TVM solver, and then these are my inputs actually for the first question to find the payment. Oh, and I even have the answer there. Okay, so we put in each of these inputs. It said 6 years quarterly, so we have to do 6 times 4 in the number of payments. Okay, it was 14% interest, 14,000 was the loan, the present value. The future value is going to be 0, and then the K value, the payments for your compounding period quarterly, is 4. And then after we do that, we solve. So we go to alpha, solve, and then that gives us our payment of 871. Now, again, it says here, answer all questions to 2 decimal places. This is money. So every question here in 1 has to be answered to 2 decimal places. Okay, so let's write down our workings. I started already. We solved for payment. I mirrored this screen on my workings. And again, my answer is 871, 2 decimal places, 82. Okay, so that is my answer. That is my workings for 1AI. Okay, so again, on the exam, you're going to be flipping back and forth. Actually, you'll have both the answer booklet and the question booklet open, so you won't have as much difficulty as I'm having now. Total amount paid for the car. Okay, so how many payments were made? Well, it was there in our TVM solver, 24. So all we have to do is multiply 24 times our payment amount. Okay, that's going to be our next answer for double I. A double I. Total payments 24 times 871.82. Okay, and I'm not sure if I did that calculation yet. I did. Okay, so there it is. And again, I rounded up. I'm going to make all those payments, and I'm going to put units on my answer, euros, 20,923 and 68 centimes. Okay, so there's my total payments, double I, and then triple I. Find the interest paid on the loan. Okay, so the interest paid on the loan basically it's the difference between how much we paid and the present value. Okay, so the difference is going to be our answer to double I minus 14,000. So I did that subtraction on my calculator, and I got 6,923 euros and 68 centimes. Okay, so that's how much money the bank is going to make off of the loan. Here, there it is, 69.23. All right, part B of the question is actually finance option B. We have a 6-year loan now. It was 6 years before, but we're going to have our interest compounded monthly. So this question, again, the number of compounding periods per year is going to be 12, okay, for months. So K is equal to 12. And actually, we're going to use the TVM solver, and we're going to solve for I. We're solving for the I, and the payment is right there, 250 euros. Okay, so find the amount. Oh, we didn't read the whole question here. It actually says there's a 10% deposit here. Okay, so 10% of 14,000 is going to be subtracted from the amount. That's going to be the amount we borrowed. So we paid 1,400 up front, and then the rest of it is going to be in the loan. So that is 12,600 is going to be the amount borrowed. So I started that already on the TVM solver. And I'm writing this input into my calculator. Again, it was 6 years, 12 months at 14%. There is 90% of 14,000 basically is 12,600. Future value 0, and I changed the PYCY to 12 still at the end of the year. And I need to solve for okay, the payments are wrong. What were the payments? 250. So it still has to be negative here because it's money out of our pocket. Payments are 250. And then I go up and solve for interest. Hello? All right, solving for interest. We're just going to hit solve there on I. It's not 14%. It is 12.2 decimal places, actually, is what they asked for. Normally, I would say 12.6%. I think that's what I actually wrote on my paper. But I did look at the mark scheme, and again, they got an answer in the mark scheme of 12.56. Okay, so get to the right page here. So this is B double I 12.56. 9.56% annual interest. Okay, however you want to call it, annual percentage rate, if you want to call it that. Okay, is there more to this question? Navigating back. State which option Brian should use. Justify your answer. Okay, so we got to look at, maybe we should look at the total amount of payments for option B so that we can compare the two. Okay, so total amount of payments, it was 250 euros times 72. Okay, that would be the total for this. And then this loan was not for 14,000. It was for 12,600. Okay. So yeah, the 1,400. Yeah, I made that down payment, but that's not really money that the bank is making. The bank is making 5,400 off of this loan. Okay, so I might want to show that those workings there for this question. C. I might want to do 250 times 72 equals 5,400. So again, I'm comparing that to the previous amount, which was 6,900. So if I had the 1,400, option B. Okay, and why would I choose option B? Because it's less expensive, that's one acceptable answer, but you might want to choose option A. What if you don't have 1,400 euros? Okay, so you could, again, in the mark scheme, it's marked as an acceptable answer. Say no deposit if you choose option A, maybe, because there's no deposit. Okay, and then the last question there, navigate back. D, depreciation. Okay, so you're losing 25% per year. Okay, you could do this as a exponential. Again, 25% less than 100%. That's what I showed in my workings. I just basically did D 100%. Whoops. Minus 25% is 75%. So each year I'm multiplying by 0.75. Okay, and the question said it was for 6 years. Okay, so I'm going to take that amount and I'm going to multiply it by 14,000, and I got my future value of the car. Okay, you could also do it on the TVM solver. Again, the present value was, okay, it's still 6 years now every year. So we're going to have to go from that, go negative 25%, start at a present value of 14,000. Okay. And we're not going to make any payments. We're just going to see how much it depreciates once per year. Okay. And again, I want to see what the future value is. I solve for future value. And I should get the same value that I got by doing 0.75 to the sixth power. times 14,000, 2491. So it's only worth 2491, 70, round it correctly. That's what the car depreciates to. There, exactly the same answer. Okay, there's the answer, 2491.70. Let's take a look at question 2. All right, so this is a topic 4, statistics and probability question, core chapter 10. Again, I wanted to point out to you that the instructions we're not going to complete this table here in the question booklet. We're asked to copy and complete the following tree diagram in our answer booklet. Okay, so I need to make a copy of this. Yeah, so I started that already. I got to get those percentages in there that I forgot to put in. So it was 0.8, 0.2. Okay, I didn't really read the question yet, and 0.1. But I know how to complete a probability tree without doing that because I know the sum of probabilities has to be 1. So there I see in my first 2 branches, those add up to 1. This branch up here must add up to 1. Okay, and again, I got some text to help me with the other branch. It is known that 10% of the stars, 10% of the stars are colored yellow. So I see that already. And 30% of the crescent moons are colored yellow. So I need to put 0.3 in here to complete the tree. Okay, and these are sweets. And again, we're going to figure out the probability that a sweet is yellow. And given that the sweet is yellow, that it's star-shaped here. Okay, so this was 0.3 as it said in the question. So now I can complete the tree. This is 0.9. That's 0.7. Okay, my tree is complete. Maybe I should have written those under the line, but it doesn't matter too much. Okay, so now question B was find the probability that it's yellow. Okay, so it could be a star and yellow, or the word or means add. Okay, it could be a crescent and yellow. And I use the word and, so that means I'm going to be multiplying some probabilities. Those are in the formula booklet. Again, I'm going to be adding for or. I'm going to be multiplying for and. Okay, so just to refer to that. So star in yellow, that's 0.8 times 0.1, and I'm going to add. So this is the overall probability that it's yellow. Probability of a crescent, 0.2. Probability that the crescent is yellow, 0.3. So that's 0.08 plus 0.06. I get 0.14 when I put that into my calculator or my mental calculation. I got that. Okay, double I is given that the sweet is yellow, find the probability that it is star-shaped. This is conditional probability. That word given is conditional probability. That's what this vertical pipe means, the given. So I see here the probability of A given B. I can just go down here and multiply those probabilities and then divide by the probability of B. And then I will actually have the probability of A given B. Okay, conditional probability. Double I. Okay, again, I'm going to do the probability that, let's get this nomenclature right here. Find the probability it is star-shaped, given that it is yellow. Okay, so I do probability star given yellow is going to be equal to the probability of a star and it's yellow divided by the overall probability of yellow that I just calculated above. So again, we can see the probability of that it's a star and it's yellow. We did before 0.8 times 0.1 right there. So we do that calculation, 0.8 times 0.1 divided by our answer to I, and I get 8 divided by 14. It's actually 0.08 divided by 0.14. And if I simplify that fraction, I get 4 over 7. I can also give it as an approximate decimal figure. I get this off of my calculator for 4 over 7. Okay. So the next part of this question, it's still question 2 continued. It's like a whole new question. Okay, we're not doing probability trees. We're going to look at statistics here and do some hypothesis testing. Again, we're given a distribution. The manufacturer specifications says that this is the percentage of their stars and crescents and all that are distributed, their candies. Okay, so here are the colors. We should see a corresponding yellow percentage in the previous question. I think we did. And then Mr. Slugworth opens just one pack of these sweets, and we want to see if this distribution is similar to these percentages. Basically, this is called a goodness of fit test. Okay, so how good a fit is Mr. Slugworth's distribution? So write down the null hypothesis. We're used to writing down the word independent. That's not really what we're doing here. We're just going to see, basically make a statement whether the distributions are the same or not. Okay, are they equal, the distributions, or are they close enough to equal that we know that there was no foul play, that somebody was putting in too many candies of another color. Okay, so get to my answer page here. C, the distributions are the same, basically. You could just say that. Or you should say the observed the observed, and the manufacturer's specs. Distributions, are the same. Okay, maybe not the best grammar, but you can put that into better words than I just did. Okay, so is there a significant difference between these two distributions? And again, we're going to look at the significance level 5% here. Kind of arbitrary, but is it more than 5% due to normal variance probability chance? Okay, because there's going to be some variance in each packet. Okay, so copy and complete. Ooh, again, like the probability tree, we actually have to copy this table and complete it. Okay. How many suites are we talking about? 80. And then we're given these percentages here that we have to multiply by 80 to copy and complete this table. I didn't work this in advance. I'm going to lose a little bit of time on the video here. So the color is brown, red, green, orange, yellow, purple. I ran out of room. Okay, so again, for the calculations, we're going to take the given percentage. So this was 15% of 80. And then 25. This was 20, 20, 10, and 10. And that should add up to 100. I do 15% of 80, 10% is 8, 12. A quarter of 80, 20. A fifth of 80, 16. A tenth of 80, easy. Okay, so hopefully those numbers, 38, 32, 48, 64, 72, they add up to 80. Okay, so again, I could do a checksum. Again, they add up to 80. I think my chart's good. Okay, so write down the degrees of freedom is the next question. How far can we go in the table? Well, I start here in this block, 1, 2, 3, 4, 5 rows minus 1. I don't have any columns. Okay, so just the degrees of freedom is just going to be 6 minus 1, 5, and that's a 1-point question. So you're not going to get any points for that. But 6 minus 1 df is 5. Okay, and then F. Find the p-value for this test. Okay, so we're told this is a goodness of fit test here. Okay, so we're going to use the TI-84. I'm going to put my expected frequency. I'm going to edit the table. Sorry, stat, edit. I'm going to put my expected frequencies, percentages. Excuse me, these are the observed frequencies that I just calculated. Okay. They don't look. Oh, these were the ones that were given, of course. Yeah, these are the ones that were given here. These are the observed frequencies. They go into list 1. The expected frequencies go into list 2. Again, what I just copied and completed, that's the table in list 2. Okay, so observed and expected, I don't think it really matters which way we do it. It's still going to figure out the difference between the two tables. Okay, so we're going to quit out of this. I just do that out of habit. And we're going to do a stat test. Okay? It's not a chi-squared test. It's a chi-squared goodness of fit test right there. Boom. Okay? There's my observed. There's my... got the degrees of freedom already. It figured it out for me. Nice. Okay, so I could have used that. Actually, not even shown the calculation. Calculate how well this fits. Okay, so I have a chi-squared statistic. It didn't ask us for that. It asked us for the p-value. And I see that p-value as 0.469. Rounded to 3 significant figures. Now G, state the conclusion of your test. Is this a high p-value? Is it a low p-value? It's a high p-value, okay? So again, the p-value is much greater than 0.05, okay? So that is, that's basically my conclusion that I'm gonna fail to reject the null hypothesis, okay? Or I'm gonna accept the null hypothesis. So again, I'm going to say 0.469 is greater than 0.05, or that the p-value is greater than alpha. So I fail to reject H naught. Okay, that is my reasoning and my conclusion, which is worth 2 points total. Question 3, another topic 4 question, statistics and probability. This time we're going to do bivariate statistics, X and Y. Okay, so here we got Aquatic Center hosted a 3-meter springboard diving event, and we have 2 judges, Stan and Min's son. Stan's scores are X, Min's son scores are Y. That's the raw data of their scores. Find the Pearson's moment correlation coefficient. Okay, so is there a relation is there a correlation between Stan's score and Min's son score? Using the value of R, interpret the relationship between Stan's score and Min's son score. Okay, so again, I'm going to lose a little bit of time here putting this into the calculator. Didn't put it in advance. We're going to go back to stat. We're going to go back to editing these tables. How do I clear it for this question? Because I just used it. I arrow up to L and hit clear. I don't want to delete my tables, okay? Or I'm going to be having to switch to L2, or L3, L4, and again, I don't want to really have to do that. I want to just use the calculator where it is. Okay, so put in Stan's score in list 1 and Min's son scores in list 2. All right, I've finished putting in those scores into the calculator. List Stan's and Min's son scores, again, making sure that they have the same match up every there. List 1 and list 2 match up on this one. Okay, so we're going to calculate Pearson's. We're going to have to do a linear regression to get Pearson's. Okay, it's not a test. Okay, so we're going to go linear regression number 4 here. Again, I want to make sure that I had stat diagnostics on. I'm pretty sure I did. Okay, and list 1, list 2, frequency list, there is none. Maybe I want to store this equation in my calculator to answer a future question to estimate a score. So I'm going to store that in Y1 by going y-vars function. And now it's going to store in Y1, calculate. Okay, so now I see a gradient, 1.14, and the y-intercept 0.578, and I'm given the Pearsons here is 0.909. Okay. So the question asked, write down the value of that. So I might put some workings in here that I used the TI-84, and I did list 1, list 2, Stan and Min Sun, and then I did a Lin Reg, and then I got R equals 0.909. There are 4 points total on this section, so I want to show some kind of workings here. That's I, double I. Again, using the value of R, interpret the relationship between Stan's score and Min Sun's score. We know that actually 1 is a perfect correlation. We're getting pretty close to perfect. I would say there's a strong correlation between the two scores. You can even say very strong correlation because it's way up there. Okay, there were scores. Okay, B. Write down the equation of the regression line. Again, I said that the gradient was 1.14 x plus the y-intercept 0.578. This is the equation of the regression line. Use the regression equation in B to estimate. Again, X is given. So again, Stan's score, he awards a perfect 10. What would Min Sun's score be? So basically I'm going to go 10. Wow, it's going to be over 10. So I could use the function, or I could just do 1.14 times 10 plus 0.578. And the estimate for C, is going to be about, now that I have it in here, I could look at the table, or I could use the function notation, vars, y vars, function, y1, perfect 10 from Stan gives from Min Sun 11.98, rounded to 3 significant figures. That's a 12.0, which again, not very reasonable. Assuming these scores might go above 10. I don't know that. Actually, a perfect 10, Perfect 10 is perfect. You can't get better than perfect. Okay, so I would have to say that's not reliable. Okay. Number one, that's not a reasonable answer, but also we have to look at our data here that we are actually, you don't see any marks here that are 10. I mean, the highest mark that Stan gave, coming next actually, is 7.5. So I would say that it's not reliable. It's not reliable, and it's because it's outside the range of data. All right, and then the next question, copy and complete the table. So again, just like before with the probability trees, we're asked to copy this table with between Stan's and Min Sun's rank. So the table is copied now. Stan's rank and Min Sun's rank, and they filled in some more information here. 1 out here, 1 there. That's the top score. Like I mentioned before, 7.5 was Stan's top score. Actually, 9.5 was Min Sun's top score, and then we had some more ranks that were given to us by the exam. This 4.5 is interesting because, again, what happened was Min Sun gave a couple of tie scores here. Okay, so we got to count down from number 1 for Min Sun is 9.5. Number 2 was 9. Number 3 was actually 7.8. And then we can see the 4th and 5th are ties here at 7.2. So we add 4 plus 5 divide by 2, and we assign these two ties a 4.5. Okay, Stan didn't have any ties. Again, top score. Start counting down to the bottom score, which was a 3 given here. So we need to fill in that table, and then we can put the data into. Sorry, this is what I got on my table. Oops, 4, 2, 1, 4. Oh, I have a 3-way tie here. I didn't even look at that very closely, did I? 6, 6, and 6. Okay, so that was a 3-way tie on that score. And they were actually the 4th, 5th, and 6th scores. So that means, if I want to show the workings there, 4 plus 5 plus, or maybe it's the 3rd, 4th, and 5th. I think it was the 3rd, 4th, and 5th. Yeah, because I got 1, 2, it was 3, 4, and 5. Three plus 4 plus 5 divided by 3, 7, 12. So that's why those 4 scores were actually, those 3 scores, excuse me, were actually a 4. So we put in these ranks, and then for the Spearmans, we're going to compare these 2 ranks by doing the same procedure that we did before on the TI-84 and putting those ranks into Table 1, List 1, and List 2 for Stan and Min Sun, and see if they agree on the ranking. Okay, so this is called Spearman's rankings for E. Find the value of Spearman's coefficient. And when I did all that, same procedure that I did before, but I put in this data, I got a Spearman's. I can do a sub S. Again, I'm going to do a lin reg just like before, TI-84, list 1, list 2. Maybe that's enough workings. About 0.933. So that's even stronger correlation than I had with the Pearsons. Okay, so double I would say they agree on ranking. You know, there's a very strong degree on ranking, very strong correlation. Okay, they agree very strongly. Okay, if, the last question, F, if we change these marks here, 9.5 to 9.1, if we change that mark, 9.5, to 9.1. Why does the Spearman's not change? Well, it's still the number one score. So the ranking did not change. It will not change the Spearman's. It might change the Pearson's because it's a little bit closer, actually. Got even a stronger correlation here. Again, we're looking at the differences between scores. And then, add them all, square, or whatever, find a difference, squaring it, dividing by all that, just like you did on your spreadsheets. So, yeah, I think it's going to be, well, I know the Spearman's going to be the change because 9.1 is still the top score. Still has a number one. Still number one. Ranking is unchanged. So that is why the Spearman's stays the same. Topic 5 for question 4. We got a calculus question, application of differentiation and integration. Okay, 2 chapters, 12 and 13. This is an old geometry question here. The straws are packed and closed. Again, we're used to open boxes, maybe in optimization problems, but this box is closed, so it has 6 surfaces closing this cuboid, and we're given the dimensions of the surface written on the diagram here. Calculate the surface area of the box, and then calculate this 3-dimensional Pythagoras diagonal that's going up from A to G. Okay, so we're asked just some basic geometry questions before we get to the calculus. Okay, so I said cuboid has 6 rectangles. Question 4A, 6 rectangles. So I'm just going to do the front and back are the same, and the sides are the same. The top and bottom are the same. So it's 3 by 8 plus 3 by 4 plus 4 by 8. Those are the dimensions. They're in centimeters. When I multiply, add, and multiply by 2, I get 136 centimeters squared for the surface area. The 3D Pythagoras, we want to find the diagonal of the bottom. Okay, this is AG. The diagonal of the bottom is 4 by 8, so that's going to be the square root of 4 squared plus 8 squared. And then we're going to square that, which is the same thing as taking the square root and squaring it. So I'm just going to leave that for 3-dimensional Pythagoras. I just add in the height here, 3D, and I get a diagonal of approximately 9.43 centimeters, not to be used later in this question. Just they had to throw in a little bit of geometry there. So those are actually in topic 3. There's a difference between 3 points. Okay, that's not 3-dimensional Pythagoras, but we had Pythagoras in the previous, prior knowledge section of the formula booklet. The formula are in there. And the surface area of the cuboid may not be in there. You just have to figure out that it's all rectangles. All right, so the formula booklet does have some formulae for topic 5. Okay, so we're going to be using some of this information to answer the rest of the questions here. So now that we know the surface area of the box, we're given actually that each week they sell X boxes of straws. So this is a profit function. That is the derivative of the profit function is this expression, okay? Where P is the weekly profit in dollars from the sale of X thousand, so X is in thousands, boxes. Find the number of boxes that should be sold each week to maximize profit. Okay, so for maximization, this is optimization. This is basically when you want to set the derivative equal to 0. So we have a horizontal tangent line at a peak or a trough on the profit function, okay? But this is actually a linear function, so it's just going to cross the x-axis, and we want to see where this crosses the x-axis. And then we're not really asked to see if it's a minimum or a maximum. We could do a sign diagram and take a look at that maybe. Okay, so that's negative 2x plus 220. Okay, so C. dp dx is equal to negative 2x plus 220. All right, so that's a negative gradient. It goes down like this. Okay, so here, the profit is increasing if we're doing a sign diagram, and here the profit is decreasing. So on the profit function itself, this is dp dx that I just graphed. On the profit function itself, again, it's this is the gradient of the profit function. So the profit function would be going up and back down again. Okay, I'm sorry, I didn't put that in the right location. The peak is here. Okay, so the profit function, the peak is there. We have a positive and negative gradient. We can analyze to see that this is actually the maximum. So we set that equal to 0. We solve this simple equation, and we get x is equal to 110,000. So that's 110,000 boxes will give us the maximum profit. D, the profit from the sale of 20,000 boxes is $1,700. Find P of X. Okay, so yeah, this is a indefinite integral that we're going to use the antiderivative of dp dx. So we're finding the antiderivative. Oh, there's the formula right there. Okay, so we're finding the integral of dp dx. Okay, and we can use the power rule for integration to find the antiderivative. All right, so I'm going to start at a new page here. Yeah, I didn't mention earlier that you can start new pages in the formula booklet. When I do start a new page, I should put the number of the question on it and say exactly where I am. Okay, so I'm on 4D. Maybe I started a new answer booklet. So again, I had to write my name on the new answer booklet and continue writing my answers in it. Okay, so P of X is going to be equal to the integral of dp dx times dx. And you can see that the integral of dp basically is going to be P. Okay, so I'm going to integrate negative 2x plus 220 dx. So this is a power of 1 here. We have no x there, so that is actually x to the 0 there if I want to use the power rule. So the antiderivative of x to the 1 is x squared. Divide by the new exponent. The antiderivative of x to the 0 is 220x x to the 1. Don't have to write that. Divide by 1. Don't have to write that either. And according to the formula booklet, I have to put in the constant of integration. Okay, and we were given some information here, and we said the profit is $1,700. Oops. For 20,000 boxes. Again, remembering that X is in 20s. So I'm going to simplify that, and I'm going to have that negative 20 squared plus 220 times 20 plus C. Okay, so now I have 1,700 negative 400 plus that's 4,400, I think, plus C. And when I don't do all that, my arithmetic, I get negative 2,300 for C. Okay, so they didn't ask what C was. They asked what is the profit function. So the profit function, I'm going to have to write as negative x squared, okay, plus 220x minus 2,300. Okay, so that is the profit function. Now find the least number of boxes that must be sold each week in order to make a profit. So basically we're breaking even. We're making zero profit, and anything more than that, again, this is as we showed in our diagram before, it's a frowny face parabola. It's going to go up to make the maximum that we found and come back down. So I want to find this x intersection right there, the x-intercept. Okay, so I can use polysmelt or the graph of this function or different ways of solving it to answer question D, the least number of boxes. So basically for E, we're solving this equation. 0 is equal to this. And this really can't be factorized, so don't try it. Do it graphically. Do it on polysmelt some other way. I'm going to try polysmelt here. All right, so again, apps, polysmelt number 9. I want to find the roots of this quadratic. So it's a second order equation. And I move my buttons here to go to next. And then I put in my coefficients. The first coefficient is actually negative 1. And then plus 220. Minus, that's okay, 2,300. Negative 2,300 was C. I think that's right. And then I want to do solve. So when I hit the solve button, the graph button up here, I should get two solutions. I get that where we make way too many boxes, I can't make any more. I'm going to start losing money on profit. And then the minimum amount to make profit. And then these are in thousands. So the tendency here, I looked at the mark scheme, I want to say 11,000, but that's not correct. Okay, we have to get above the x-axis. So we have to go more than 11,005. Okay, so the solution for x1 is actually, actually the solution is 11.005 and something, okay, but the answer is going to be 11,006. Okay, so 11.00505 or whatever it is. So I have to make one more box to get above the x-axis there. So that's 11,006 boxes to get into the black. Last question on the exam, last question on paper 2 of this specimen paper. It's a topic 2 question, functions, modeling. We're going to find a model. We're actually going to find a quadratic model. And so we're going to use actually some of chapter 6 in our AI textbook to answer this question. Okay, so the breaking distance is defined by the data in this table. We want to create a quadratic model that's shown here. It only has 2 terms. I don't see, I see ax squared plus bx plus, again, our variable's s. I don't see a c. I don't see a y-intercept anywhere here. So that's because we're going 0 for speed. We don't, the y-intercept is going to be 0. So we're going to set up a system of equations here to find these coefficients p and q. So we have our quadratic model. So they built, again, I said 0, 0 goes through the origin here. They built a model. They started building a model using this first speed here. Well, 6 squared, wait a second, that's 36. So why is that a 6? Okay, well, again, they put in s is 6. So they actually came up with this first equation. We'll call that equation 1. They came up with it by doing p times 6 squared plus q times 6 equals 12 for y. Okay, so that's 36p plus 6q equals 12. Divide all of those by 6, the common factor, and you'll get 6p plus q equals 2. So that's where they got that first equation. Again, AI is write down the second equation for this using the speed of 10 and a stopping distance of 60. All right, so that's AI, or 6. Again, I write that in my answer book that this is 5. AI. Okay, so write down the second equation. 60 is the stopping distance. 10 is the speed. Okay, so again, I'm going to do p times 10 squared plus q times 10. And again, 60, that's 100p and 10q. Simplify it, divide everything by 10. So now I'm going to get a simpler equation here that looks like this. Okay, so there is my other equation. And the first equation that, again, this is equation 2. The first equation I had was, maybe I'll write this 6 on the other side just to make myself a little bit more comfortable with systems of equations. Again, I can do this on polysmelt through simultaneous equation solver. I'm going to subtract equation 1 maybe from this equation and see if I can eliminate a variable. That was my other equation 1. And if I subtract the second equation from the first equation, I get 4p is equal to 4. P is equal to 1. So then I can take that p equals to 1 and throw it into either of those equations up there. 6 times 1, that's equation 1, plus Q equals 2, and I get Q is equal to 2 minus 6, negative 4. Okay, so those are my solutions for P and Q. That's what they asked for in double I. Okay, first I had to write an equation. That's either one of those, I guess. That's really my equation for I, and then double I solved the system of equations to find P and Q. Okay, so now I have my model, and I'm asked to find the vertex of the model, okay, for B. Find the coordinates of the vertex of the graph. Now I can do this algebraically. I can do it graphically, a number of different ways to do this. I'm going to stick with the algebraic way. Okay, so our model for D, the stopping distance, again, I know that P is actually equal to 1 now, and Q is equal to negative 4. So that's actually my model for stopping distance. So A is equal to 1, B is equal to negative 4, and as I said before, for a quadratic, C is equal to 0 for the y-intercept of this. So I can just do some calculations here. Well, I lost my page there, and I can just find the axis of symmetry. Okay, quadratic functions. Back here in topic 2, we're given the equation for the axis of symmetry. Right here, x is equal to negative b over 2a. Okay, so negative b, or x is equal to negative b, which is negative 4 over 2 times a, which is 1. So I get 4 over 2, I get 2. Okay, so now I can plug in 2 to my model to find the y-coordinate. So d of 2 is going to be equal to 2 squared minus 4 times 2. That's 4 minus 8. That's negative 4. So these are the coordinates of the vertex. Negative 2, or 2, comma, negative 4. That's what it asks for. Find the coordinates of the vertex of the graph. I could have done that graphically by finding the maximum. All right, so it's kind of significant at this point that we note that at a speed of 2, it gave us a negative stopping distance. To see that later. Okay, doesn't make much sense. So using the values of the table, do a sketch, okay? Do a sketch of the graph, okay? Clearly showing the vertex. Again, they give us the specifications, so I think maybe I should have done this on the calculator. Put this into y. Oh, I got to quit out of the polysmelt. Y equals, get rid of that old thing there, x squared minus 4x. Okay, that's my function for stopping distance. Okay, and then I want to set up the window the way they asked in the question. Okay, so they said 0 to 10, negative 10 to 60. 0 to 10, so I like to start at negative 1, so I see the y-axis. And negative 10 to 60 for y. Okay, those are the window settings that they require for the sketch. So it looks like this. There you go. Okay, so when I do my sketch here, it's only worth 3 points. I looked at the mark scheme. Again, we have to have labels on our axes and scales, and we have to go through some certain points, okay? we have to see that the vertex is down here below the x-axis, and that it has this quadratic shape. And we're given this point here, 1060. It should go through 1060 way up at the right-hand side of our sketch there. All right, so this is question C, or 4C. Maybe I'm on a new page again. Really eating up these answer booklets. All right, so again, the scale goes up to 10 for the speed, 5, and then it went through some values here. Sorry, 1, 2, 3, 4, 5. It went up through 4. Yeah. So again, I don't really need to draw this part over here to the left. It actually starts at 0, 0, and then goes up to 60. Okay, and then this is, that's a 5. This is speed in meters per second. And this is distance in meters. Okay, so I might get 3 points for that sketch, something like that. Okay, D. Hence, identify why it may not be appropriate. Okay, this is why it's not appropriate. Right there. Okay, we have negative stopping distance. At slow speeds, not a valid model. In that part of the domain. Maybe at higher speeds, it's okay. Use model B to, for question E, find how far does it take us to stop? How long does it take us to stop at 20 meters per second? Oh, we're going to use a different model now. Okay, so model A is no good. We're going to use model B now. Okay, so model B, we're asked to find D of S for model B. We could put that into the calculator, or we could just do the calculation directly. Since I'm not sure I'm going to be graphing this, I'll just do it directly. 0.95 times 20 squared. New model, in case we made a mistake on the other model. It reset the question for us here, times 3.92 times 20. So that's 301.6 meters. You could say the exact answer here, or you could round it again to 3 significant figures. Again, this is model B, and I might want to show that calculation that I did there. 0.95 times 20 squared minus 3.92 times 20, and that's equal to 301.6. I could say 302 meters, or the exact answer. Okay, the exact answer is important because question F, they ask us for percentage error. Okay, so we are given the exact, actually, braking distance. The model only gave us an estimate of the braking distance. Okay, again, I need to use the error formula that's given in topic 1 right there to figure out the percentage error. And again, I have these absolute value brackets, basically making this positive, but I could put those in my calculator. So the calculation that I want to write down is going to be do I have enough room? Is it going to do it? Did that again to me. Okay, so I'm going to do another thing here. This is 4E. Okay, so the error is going to be equal to, again, the exact value, which is 320, minus our estimate. I'm going to use more than 302. I'm going to be more accurate than 302 because I want to be as accurate as possible. And then I'm going to do that times 100%, and I should get a percentage error. I'm looking through my workings here. Did I do that calculation? I want to show you that I can do that. I didn't do it. Okay. Oh, the approximate went first. The approximate went first. But again, it doesn't really matter with the absolute value function which way I did it. So I'm just going to, when I make the calculation, I'll do it the correct way. Okay, so the absolute value function, I like to find it in the catalog. You can find it through the math key. I like the catalog because it's the first one. Okay, and I want to do a fraction in here, so I'm going to do that, and I'm going to do our approximate value, which is pretty darn precise, minus the actual, or the exact value, divided by the exact value. And then I'm going to multiply that by 100 according to the formula to change it to percentage. And I get a percentage error of 5.75%. Okay? .75%. Okay, last part of the last question. All right, somebody's sleeping at the wheel here. 1.6 seconds to elapse. Oh my God, we're going to run in. We're going to hit somebody before we hit the brakes. Okay, because the during this 1.2 second reaction time, the vehicle continues to roll along there. Again, when you guys take driver's ed, you probably look at this reaction time. So we're just basically going to do the time, speed, distance triangle, and make sure that we notice that the traffic light, yeah, the truck, it's a truck, even worse, is red, and that we got to stop within 330. Okay, so how fast can we go and still stop in 330 meters? Okay, so again, we're going to take this speed times time is distance. So we're going to take that speed, S, times the 1.6 seconds, so that you can see the seconds cancel out, we get meters. And then we're going to use our model B that we just used to solve an equation. Okay. So this is 4G. And again, my equation, 330 meters equals, again, the model. Well, I said 1.6 times S first. Okay. And then model B, 0.95 S squared minus 3.92 S. Okay. That is the model. Okay, so again, I want to make it 0 on one side so I can solve this and write it as a quadratic. 1.6 minus 3.92. I'm at the end of the exam here. I'm a little tired. I don't want to do any mental math. Those combine to negative 2.32 for S. Okay. And then I'm subtracting 330 from both sides. So this is the quadratic that I want to solve. Okay. Again, not very likely to factorize this. I could graph this and find the intersections, but we're going to go to the app. We're going to do it on Polysmelt. I think that's what I actually had in there before were these coefficients. I had 0.95. Yeah, I did. 0.95, enter minus, or you could say it's negative 2.32, and then minus 330, our stopping distance. Yeah, solve it. Okay, so I got a negative time here. I'm going to ignore that, and I'm going to say 19.9 is actually the maximum possible speed of the truck. So not even 20. The maximum speed of the truck is going to be 19, approximately 19.9 meters per second.